Okay, so the trickle of people joining seems to have slowed down, and I think we can get started. So I want to welcome everyone to today's Postgres World Webinar, an open approach to asynchronous multi-master replication with PostgreSQL. We're joined by Hari Kiran, Customer Success Evangelist at PG Edge, and Katie Motika, Engineer at PG Edge. They're going to discuss Spock, an open source available PostgreSQL extension for logical replication that supports creating multi-master clusters. In this webinar, they're going to go over the architecture and functionality of this extension and the type of use cases that can benefit from a multi-master cluster. My name is Lindsay Hooper. I'm one of the Postgres World organizers, and I'll be your moderator for this webinar. So a little bit about your speakers. Hari is a seasoned database engineer with nearly 17 years of experience in multiple domains in the IT industry, including healthcare, banking, project and portfolio management, and CRM. He's passionate about PostgreSQL and has helped customers across various geographies with database administration, enterprise implementation, security, and hardening, backup and recovery, and performance tuning. He is a regular speaker at Postgres conferences like FOSS Asia Summit, PGConf Asia, and PGConf Down Under in Australia. Katie's a software engineer with PG Edge who has spent the last 10 years working with Postgres. So it seems like we have almost 30 years of experience on the line, and I am so excited to see what y'all have to say. Welcome to you both. A few quick notes for our attendees, and then we're going to get started. So the first is that I've put all attendees on mute to avoid background noise and to preserve audio quality. Visually, we recommend putting Zoom in side-by-side speaker mode so that you can see the presentation in the demo and our speaker. The second is, yes, we are recording this webinar, and it'll be accessible on the Postgres conference website by early next week. And finally, my favorite is that questions are encouraged, and they're going to be answered throughout the session. You should ask questions as they come to you via the chat function in Zoom, and then I'll read them off to our speakers. So with that, I'm going to hand it off now. Hari and Katie, go ahead and take it away.
Thank you, Lindsay. All right. So the agenda we have today is, we'll look at what multi-master in Postgres is and how PG Edge as a product, PG Edge platform as a product is going to add that multi-master replication features to your Postgres ecosystem, right? And then we will also be demonstrating a two-node cluster, just spin up a two-node cluster which we have created on a couple of AWS EC2 instances, right? And we will also do a Docker demo of just spinning up two Docker images and see how we will be able to set up PGH platform on those two Docker images right off the bat, right? All right. All right. Why are we even looking at multi-master as one of the use cases that Postgres requires, right? And why now, right? Why multi-master now? We're looking at some of the features set here, right? Low latency, ultra high availability, and so on and so forth, right? If you take a look at the low latency, right, the reduced data latency is for some of the faster web page load that is a imminent requirement, right? Some of the use cases like e-commerce applications or the IoT applications, there's a ton of transactions that come through, a ton of transactions that are lightweight. So you are looking at multi-master as one of the solutions to make sure the latency between your application layer and the database layer is as less as possible, right? And some of the local writes on the distributed nodes result in reduced latency because the application and the databases are in the same line of sight. And it provides a seamless experience for users, regardless of wherever the location they are conducting the business from. And ultra high availability, right? Achieving unprecedented ultra high availability, right? Whenever you're looking at a multi-master replication, it allows multiple nodes to accept both read and write operations, right? And simultaneously, eliminating the single point of failure associated with the traditional primary and replica architecture. We'll take a quick look at the diagram on the next slide. On staying on the multi-master replication and why the multi-master replication has gained such an important importance in the Postgres ecosystem, right? Another important feature is the data residency, right? And making sure the data residency and the data sovereignty to be stored in multiple geographic locations. The data residency is more of storing the data physically, and the sovereignty is making sure we are abiding by the compliance that country needs to go through. Right? And one of the good examples is the GDPR and the EU. Right, that's some of the data residency use cases that we are actively working on with some of our customers, and looking a lot of success in this area. And in addition to this, future-proofing the entire database infrastructure is an important component. Right, implementing multi-master replication makes sure the entire database infrastructure is future-proof, right? Adopting a lot of scalability models, adopting a lot of high available architectures that are available in the Postgres itself, right? And Postgres has these extensions from a very long time, right? Though Spock has been based off of the PG logical extension, which we will be taking a look at in our due course of the webinar, right? And another important feature that alleviates the multi-master application use cases is the optimization for network edge, right? Network edge, and we call it as closer to user, right? One of our explicit design goals at PG Edge distributed Postgres is to support the distributed databases across from the edge, right? One of the reasons why the company is also called as PG Edge, right? And the two other features that we have here, right? The fully managed database as a service and access to the data dashboards and stuff. Those are part of the SaaS platform of PG Edge, which is the PG Edge Cloud, right? We wouldn't be talking much about it, but if time permits, so we'll take a stab at PG Edge Cloud and see how the whole ecosystem has is been built. Now, the diagram that I was referring to, right, the multi-master. So on the left-hand side, we have the traditional replication model, which has been there since decades, I would say, right? I mean, the last version that I worked on or started working on Postgres was 9. And then we had replication, the primary and the read replicas available from those versions onward, right? So the traditional system is, you've got a bunch of computing engines available. Your IT infra is, laid out in such a manner that you've got, multiple computes. You've got a primary database server where your application is trying to communicate to send across all the reads and writes. Now, the read replicas also played a little bit of role. We send out our read-only queries. Now, why we need multi-master replication now, and then the fast forwarding, and then making sure our entire database infrastructure is future-proof, right? The multi-master cluster is the way to go about now, right? So you have your compute engines, and then your compute engines, the application, the entire stack has got its own database data sets to play with, data sets to read and write from. And eventually all of your database nodes get into a consistent state, right? They are all connected, synchronized, and asynchronously trying to make sure that all of the transactions that are coming from your application stack is eventually synchronized on all of our nodes. Now, the Spock is the extension that we call, right? Now, Postgres's extensibility allows the capabilities of customizing your functionality, tailored to a particular set of use cases, particular set of needs that our applications and the entire data sets would like to go about, right? And Spock is one of the other extensions that that's an openly available. The source code is available on Git. You'll be able to look at some of the code that is written on the Git, right, and see what exactly is Spock is built off of, right? And Spock is the one, the extension which supports the asynchronous multi-active replication, right? And whenever we are talking about a multi-master replication, you've got multiple application layers, multiple application containers, or the different components of the application trying to pump data and then pump data in a simultaneous fashion, in a concurrent fashion. In those cases, conflict resolution is an important piece of the puzzle. And Spock has the out-of-box conflict resolution, and the conflict resolution which also gives us a lot of monitoring and management around it, right? Which is better error handling. You look at what exactly is the conflict that got arised, what is the exact resolution that was applied, and what is the exact originating node and the exact node where the conflicts were applied and changed, right? And making sure the eventual consistency that we are talking across all of the multi-master cloud instances, multi-master database instances are synchronized, and then all have the source of truth when we talk about the eventual consistency. And like I said, any conflict resolution should have a rock solid monitoring and integration in place, right? That's where you would look at, hey, what is the conflict that we had arisen, right? Where is the exact conflict originating from? What was the exact conflict? So update wins or no. We have seen a lot of conflict that are already available, right? We haven't reinvented any of that stuff. So we are leveraging what some of the conflicts that are there, and made sure that Spock is supporting all of those conflict resolution use cases. And obviously, whenever you're talking about conflict resolution, performance comes into picture, because there are a lot of transactions that are happening across your nodes, and making sure performance is one of the important stuff that we took into account, and made sure all of this multi-master features that we are baking into Spock is not hampering the performance or the stability for that matter, right? And the data residency that we spoke about, right? Meaning you have specifically having the support for data residency, and geographically scale out via selective replication, and then partitioning the tables in such a manner that you have specific partitions lying in the specific countries, and so on and so forth, right? And then there are out-of-box support available in Spock for setting up your rules around which data goes into which data set, which data center, and then which availability zone. You can go as granular as, hey, this is the partition where I will pump in all of the EU data. So it goes into the EU region and making sure the PII and the Spock capability is taking care of the data residency. Right now, from a selective replication, right? So you can go ahead and have the row level security and making sure the granularity at which you will be able to go ahead and set it up is to the row, right? Now you can have a row level security, row level replication that we will be able to set up using the Spock, right? I'll let KD speak about the Spock overview of it and look at what are some of the components that help Spock to set it up.
Hey, everyone. I think you all just witnessed a perfect transition from one microphone to another in the same room without any feedback. Let me share my screen. So on this slide, I've got an overview of the Spock objects that we're going to be creating in this demo. Like Hari said, it's going to be a 2-node cluster where we're setting up full multi-master replication. What we're going to be doing is registering one node as Spock node N1, the other is N2. We'll be creating a replication set named demo replication set on both of those machines. I'm going to be using PGBench to generate some data and add all of these tables that are listed here into that replication set. Then I will be creating a subscription on N1 to N2 that's going to connect to N2 and create a replication slot, and do the same thing with subscription N2, N1, which goes back to N1. Finally, you add the replication sets to those subscriptions, and then you've got a multi-master 2-node cluster. Another thing I just wanted to show before I get started is this node control CLI that I'm going to be using. Most of the commands I'm going to be using are the Spock ones, specifically using stuff in the Spock extension. So this example of node control Spock node create with the inputs of the node name, the DSN connection information, and then the database name is kind of the outline for all the commands I'm going to be using. So here I have 2 connections. This blue screen is actually an EC2 machine in EU West 1, and the green is in US East 1. And I'm going to begin running those node control CLI commands of Spock. This one is creating or registering that node as a Spock node. Then I am creating the replication set, rep set create, demo rep set is the name of the replication set, and then again, the database name. Next, I'm creating the subscription. Here on N1, it's subscription N1, N2, and that host IP address is the opposite node that I'm connecting to. Do the same on the other side. So now I'm able to go into the database and select from the Spock table that shows if the subscriptions were not set up correctly and the nodes weren't connected, this table would only have its local Spock node subscription. But since it shows that N1 and N2 are both here, it means that subscriptions have been set up successfully. For the next part, I'm going to use PGBench to initialize some tables. And since PGBench generates the same data on both sides, I'm able to just do that same command on both sides. If it were different data, you would probably want to do a dump from one side to the other to ensure that they match exactly before you finish the rest of this. Next, I'm going to connect to the Postgres database and run some alter commands. These are going to change the balance columns on a few of the tables to log old value equals true. And the reason I'm doing this is because typical conflict resolution is going to be first in wins or last in wins. I've got to connect to Postgres. Yeah, so in a typical case, first in wins or last in wins means that if there was a conflict and two values were updated on different nodes at the same time, you could potentially lose data because it would choose only one of those values. With this alter, you're shipping the delta of the original value and the new value of the column so that those can be summed together, and therefore you get the right value at the end of running the PG bench. Now that those tables are there and altered, I'm going to add them to the demo rep set, which is that replication set that we're using for this example. You can see an error here. It's really a warning. This demo rep set that I've created is for replicating inserts, updates, and deletes. And that requires a table to have a primary key. So this particular one, the PG bench history, since it doesn't have a primary key, it can't be part of this replication set. So it's skipped in this step. There is an option to create a replication set that does inserts only, in which case you could add the history table to that replication set. Next, I'm just adding that replication set demo rep set to subs N1, N2, and sub N2, N1. Here, where I will connect to Postgres on both nodes at the same time, I can demonstrate we've got this teller table with a filler column, and on node 1, I'm able to update it on the filler column to say node 1. Selecting shows that that's been updated on node 1, and on node 2, when I select, it's been copied over. In the same way on node 2, I'm going to update it to say node 2 and show that that has also been replicated. Yep. So that's just showing that both sides can take read and write commands. Now for the fun part, I'm going to run PG bench on both sides. I'm doing a rate of 100 transactions per second for 30 seconds with no vacuum. It's single threaded, but it's running on node 1 and on node 2 at the exact same time. I apologize for the very boring 30 seconds in a live demo. Here you're able to see that on both sides, the sum of the T-balance fields in that PG bench tellers table is both equal to 266,235. And like I said, if you do this quick start and run this yourself without doing those alter commands, you'll actually get different values for the sum on all of the nodes. So it's kind of a cool conflict-free delta apply data type that we have in Spock. I'm going to hand it back over to Hari now to do a similar example, but an even quicker start using the Docker Compose.
Thank you, Derek. That was a pretty smooth transition again, I would say, and a pretty easy way of looking at, hey, how do you set up a two-node cluster? How do we go about doing a quick conflict resolution? How do we look at, hey, is there a conflict that we had seen, or how do we look at the Spock resolutions and stuff? What I'm going to be looking at is a quick example or a quick demo of how do we set up a Docker container and make sure you have the same setup that KD had showed, but in a more easier fashion like KD said. Right? So what we recommend is, you hop on GitHub and look at the PG Edge organization and the repositories under. One of the repositories is the NodeCTL repository that you are seeing now on the shared screen. Right? This is the repository which takes care of, NodeCTL is the utility with bunch of Python and some of Terraform and stuff that is available inside. When you look at the code, you'll be able to see what the exact magic that is happening under the hood. Now, the Docker is already available inside NodeCTL. And if you see the folder here, Docker, this is the folder that has got all of the requirements for you to set it up and make sure Docker containers, the two Docker containers are created and set up the multi-master replication between them. Now, let's go ahead and quickly see. Now, I've already checked out the code on my end. I've not made any changes to the stuff. No, I'm looking at what exactly are the components of or the contents of that Docker directory. Right? Two important files, I would say. One is the obviously the YAML file, which makes sure how the Docker Compose behaves. I don't know what the Docker Compose tries to provision, and the Docker file, which has all the metadata and prerequisites for us to go ahead and spin up the Docker images and stuff. Now, these are the two files I was talking about, right? The Docker file.el9 and the Docker compose.yaml. Let's just quickly take a look at the Docker compose.yaml file. Simply creating two services, two nodes, and then making sure they are using all the metadata that is available on the Docker file, right? So Docker file.el9 that we have. And we are attaching a couple of volumes and creating, hey, where do I store my data directory? What is the data directory that I will be pumping my PG bench or some of the pilot changes that I'm going to be doing, and related to the ports that will be open, and what is the communication that we would want to have between these two PG Edge N1 and PG Edge N2 containers. This is the file I opened on my screen. I said I already have the Git code checked out on my end. This is the simple Git code that I have got from GitHub, and which has all the files that we were talking about. Docker Compose is what we saw now. Let's just open it up. And the two services that we wanted to have, right? The Node 1 and the Node 2, and the networking between those two nodes, and what is the data directory that we would want to create. And the other file is the Docker file, where we are warming up the nodes with, and then what is the metadata that we want to push to, and what are all some of the things that we want to have, right? The two things you would look at is the bootstrap.sh, which is a shell script file that takes care of doing all the steps like creating the Postgres instances, making sure what the parameter changes that needs to be there as part and parcel of either PG16 or PG15 database that we are provisioning, and all the Spock functions and Spock commands that KD had just shown, right? The whole orchestration, the entire orchestration of what KD had done is completely baked into this one. Right? Now, if I go ahead and say Docker compose build, right? This is going to build my two containers, and then see hey, what are all some of the things that needs to be installed on those two nodes, right? And then the images are ready at this point. Now I say Docker compose up, and we will be going ahead and creating these two PG Edge N1 and N2, and making sure all of the changes that we need as part and parcel of the setup, Postgres, create PG Edge, create this Spock extension, and then change some of the parameters that we have seen as a best practice, right? How do we go about creating the users on both the nodes, all of the stuff, right? Now we'll be able to quickly do all of this stuff. This is the exact same thing that KD created on her side, in a much more easier fashion, like we said. So if you see, it is creating the extension, it is creating the stuff that we had seen here, right? So creating the node, creating the rep sets, creating the sample table, now we call it as foobar, and the subscriptions and replication sets, right? Now, we have created the Docker images. Now the Docker images are ready, the containers are ready. We can just go about log into these and see. All right, so these are the two images that I have, and let's go ahead and log into these terminals. Let's use the external terminal. Boom, boom, boom. All right, so we have both of the N1. Let's also open up the and containers, the N2 also on the terminal, and make sure that we also have the font legible there. Right. So we have got both N1 and N2 available here, right? And this is N1, and then we have got N2 here, and let's see. Just a simple sourcing of all my environment variables. I'm going to be doing that now. And which is 16. It is 16, right? This is just making sure, right, whatever the database that I created, what port I am on, how am I connecting to the database, and so on and so forth, right? So we have a database called as demo that's created on both of these. 16, it is 16 source, say, so both of these nodes have the Spock extension. Let's just take a look at some of the Spock extension related stuff, right? Plus making sure so we had taken a look at some of the Spock extension, and then what are all available as part and parcel of Spock extension, right? When we spoke about some of the conflicts, some of the PII for the data residency, right? These are the tables, right? These are the metadata tables that help us to make sure how the entire Spock extension is laid out, right? How the landscape of the Spock extension is, right? So we've got conflict tracker as one of the table. What is the node that you are on? What is the local node, right? A few of the folks on the Zoom chat are asking about, hey, is it no, built off on top of no PG Logical? Yes, PG Logical is definitely one of the source codes that we looked at and we used and then forked off of it. And on top of the PG Logical, we added all the enhancements and the multi-master aspects to it, right? Now, the node is one thing, I would want to make sure what is the exact thing we have there. Spock. Right, so these are the two nodes that we have in place, and you'll also take a look at that. What is your exact local node that you are connected to? Right, so you are connected to the node 1, and then the same thing will happen on the node 2 also. Now, there's already a table that got created within the Docker orchestration itself, right? We have created this a sample table, and then we did not populate any data into this one at the moment. Right? So we've got 0 records into it, right? Both of the val1 and val2 are simple columns, right? One is an integer and so I would go ahead and say insert into bar values from node 1. Right, so I've got one insert into this foobar table. So ideally, what we should be looking at is that insert has to be available on the other N2 node also. Right, let's just take a look at it. So we've got that foobar table, and we got that. Let's see if Word has that data. Boom. So we've got the data that we have inserted from it. So now the easy way of looking at it is what we have done now. Right? We inserted one record, made sure that insert is populated onto the on both the nodes or not. Right. So that's the very minimal setup that we could come up with, and then the Docker is like you just hop on GitHub, download the node.ctl, check out the node.ctl, look at the Docker folder, and take a stab at how to go about setting up your Docker. Okay, let me pause here and see if there are any questions, comments, stuff.
We have so many questions, and Hari, I've noticed that you've been answering some as you've gone.
Yeah.
So I'm gonna pass over those because they seem to have been answered. So the first one, what about recovery? Each instance process transactions by multiple backends, but recovery goes in single mode, as I remember. If one instance restarts and tries to do recovery, it has a chance to catch up actively working nodes, ? Or do you use the kind of throttling here?
So may not be possible to answer all of the questions. So we will be coming up with a follow-up as part of the blog and say, hey, these are the questions that we have got on our webinar. Some of the questions that I could answer right at the top of the bat, and I could, and we will have to take a look at some of these questions and see, hey, there are follow-up questions that you will have. Hey, this may be the scenario that you have on your mind when this question popped up. So we'll do that question and answer dialogue via a blog, and probably, Katie, if you want to take a look at the PG Edge Cloud and then show our participants how the PG Edge Cloud looks, maybe.
And then come back to questions.
Yeah, and then come back to questions. Yeah. Does that sound okay, Lindsay?
That sounds great.
Perfect. I'll just go ahead and stop sharing.
Okay, so I'm going to share my screen and show the PGH Cloud that we have. So one thing that we skipped over with a lot of this is that infrastructure creation. We're kind of going off of EC2 instances that are already up. So this is kind of the answer to that quick configuration. Using the PG Edge Cloud product, you're able to name a cluster, pick some regions that you would like to spin up some instances in, give the database name, the user and password, choose your instance types. And right now it's a bring your own account by providing this ARN for an IAM role. Clicking deploy cluster will create all these EC2 instances in new VPCs in your AWS account and handle all of the infrastructure for you. We also are going to support multi-cloud, so it won't just be AWS instances. And just to jump to one that I've already got created here, this is the one I was actually running the platform commands off of during the earlier part of the demo. So I was on US East 1 and EU West 1 while showing that. There's a indicator that will give you the status of each of those nodes. So since I was only playing around with 2 and had cut the third one out of the replication, that one shows up as having an issue. On this site, you're also getting information about each of the servers. Their connection strings are all available in one place, including metrics and logs from both the CLI and the Postgres error logs. And this is kind of cool because you could have 3 nodes in 3 different regions and 3 different cloud providers, and you would have everything in one spot to look at. Cool. There are 15 minutes left, and one of the questions was asking about showing forcing a conflict and showing what the resolution is and what sort of like monitoring Spock offers for that. So I have that ready to show real quick, and then I think if we're good, we'll leave the last 10 minutes for questions after that. Sure. Cool. So again, using that same table, the PG bench tellers, I'm going to begin a transaction on node 1, where I'm going to update that string to say node 1, and then I can select that same part on both nodes. It still says node 2 from the previous thing, so I will change this to something else. So I'm going to update it to just say node 3 on node 2 before committing it on the other side. So it still says 1, and then when I hit commit on node 1, it says node 1, and on node 2, it overwrote the node 3 and replaced it with node 1 because the start of the transaction was before I did the update on node 2. Let me just move this to the top of the screen. What I can also show is this Spock.resolutions table, which will allow you to audit when a conflict was resolved, what the choice was made, and the timing and everything. So you could add alerting and monitoring off of this table. So you could see that this just happened. I'm on node 1 right now. It decided to keep local as a conflict resolution, and it actually gives you the local tuple with node 1 and the remote tuple of node 3. So that covers one of the questions about demonstrating the conflict resolution. And like we said, this can be configured to different conflict resolution rules. So you could make this a lot more complicated and test it out yourself with the quick start. So since I covered that.
Ready to get back to questions?
So
Okay, a tangential one. Does Spock deal with read after write consistency issues due to PostgreSQL replication lag. Note that this is not about conflict resolution, but about data lag due to asynchronous nature of the application.
And that's, sorry, is that up at the beginning or is
Up
that?
at the very beginning, yep, does Spock deal with read after write consistency?
It is going to be, sorry, I'm checking out the check now. If you're inserting onto node 1, and then on node 2, someone determines if that a customer exists, does not see it, and then does a select, that is going to be dependent on your replication. What we encourage is either using a Spock friendly configuration where if you have a customer that you're inserting on master 1, whatever that application's doing in that time that you're working on it, it's going to kind of stay on master 1, especially with the global situations. Like if you've got a customer on the East Coast, you're doing interactions with that, and then you're going to check to make sure it was created and do some other things. If that all happens on node 1, and then the reporting and monitoring can then be done on any node, I think that covers that sort of situation, because right now it is dependent on that replication lag going through the back. You get the benefit of being able to write to any node with this, but there is the replication lag depending on how far away the nodes are too. There was another question that I saw about the non-deterministic functions, like timestamp. That isn't going to be an issue with Spock because it's doing logical replication of like the resulting values. It's not going to call that same function again on any of the other nodes. So if I'm understanding the question correctly, that's something that's covered.
Brilliant. Question, has this been tested with timescale and Citus Columnar?
It is work in progress.
Any issues that will be foreseen or breakages to the replication? So any foreseeable issues or breakages when it comes to replication?
Where is the question?
Yeah, I think a lot of work has been done on the support and the stability. So there isn't anything I can think of that would break replication. I think there was another question asking about if replication fails. And obviously if there's a network issue, that's.
So the, I mean, I would like to know what is the complex data type limitation is, though, for starters. Does PG Edge replicate newly added tables automatically? The answer is no. You have to have it as part of the rep set, and then it starts. So it's the usual way of, hey, I add the table to the publication, and then subscribers are receiving all of the transactions. Okay. So similarly, you will have to create the table, add them to the rep sets, and make sure it's part of the subscription.
Wonderful. The next question is, how do you handle sequential unique columns of a table?
As long as they are primary keys, we will replicate, in any way.
Great. Can we connect it to Apache of Biz, which has a single database?
I don't know what is an Apache eBiz. If it works with Postgres, and if it has, if it works with Postgres 15 and above, why not?
Great. Let's see. Do we have support for extending this monitoring to Grafana or PG Watch? Also, is any support planned for cloud native platforms like AWS, RDS, or GCP?
Right. I did answer that question saying yes. There are endless opportunities as long as, I mean, we currently use Prometheus plus Grafana pretty extensively with our customers for monitoring and management. And the combination of Grafana plus Elk Stack, or whatever the monitoring that some of the customers have, the integration should be possible. Right? There are no blockers there as long as we have the monitoring engine, agents, and then they're talking to each other.
Great. Does this extension, or can this extension be integrated into existing PG Logical?
They use the same slots and stuff.
Yeah, it's pretty much the same infrastructure and the low-level APIs that are part and parcel of the PG Logical. So yeah, should be able to lie together.
Great. How to migrate from PG Logical to PG Edge? How smooth is it?
It definitely is not a one-click migration that is available now, but there are procedures in place that we are working actively with our customers to make sure, hey, we have a single Postgres primary, which has got a bunch of logical replicas using native or PG Logical. We are able to transition them from PG Logical to PG Edge Spock.
Great. Is there support for listen notify for replicated data?
Not yet.
Are there any plans for it?
If there is enough use cases and requests from our folks, why not? Yeah.
Wonderful. Okay, so I think this might be our last question. How about partition handling with replication setup? Is it as smooth as with push via partition route? Sending it to you so you can read it.
How about partition handling with this replication setup? Is it as smooth as with publish via partition route option? Yes.
Brilliant. We have a few more minutes. Are there any more questions?
One more question. Is there a central service that manages the nodes, or is all this handled through the PG extension with metadata tables for management? Could you wanna take a stab at it? And talk about
So there's no centralized service that covers all the nodes. They will do all of the conflict resolution locally, and with platform, you're able to configure any sort of management stuff that you want to on top of that. But in cloud, there's automatically configured things for sort of that quorum and voting if it's appropriate for something. But all the conflict resolutions happen on a specific node.
Wonderful. And finally, is there any background process responsible for handling PG Edge, or does the architecture remain the same?
So the traditional native logical replication has the apply workers taking care of the stuff on the target side, right? We're using the same infrastructure, low-level infrastructure that's there in place. Like I said, we do not want to reinvent the wheel. Now there's PG logical, which is there. There's native logical replication that is available. With the strong fundamentals and foundations, we added a lot of those features that needs to be part of the Spock to make it more powerful. So yeah.
Great. So I think we've somehow made it through all of the questions in exactly 1 hour. So with that, I want to thank you, Katie and Hari. Wonderful, wonderful presentation. Really, really exciting stuff. And I know a lot of people are giving me feedback here that they're excited to get their hands dirty with Spock. I know PG Edge is going to be back late summer, early fall with some more Postgres World webinars. So keep your eyes peeled for that. And regardless of where you are, whether it's morning, afternoon, or evening, I want to thank you all for joining us. And I hope everyone has a great rest of their day. Thanks so much, everyone.
Thank you so much.